Hello, students. So I'm going to explain Chapter 2, Unit 2.2 in this book, Advanced Function Grade 12 for Ryerson. Unit 2.2, the factor theorem. So I'm going to start explain to you example 1. So the example 1, use the factor theorem to find the factor of a polynomial. It's given a polynomial and try the factor. Now, I'm going to write it on paper to explain to you. Now, example 1, Unit 2.2, page 95. So the factor theorem for this function, P and X equal to X exponent 3 at 3X exponent 2 minus 3X minus 2. So we're going to find a factor fully divide this polynomial without remainder. Now, and the book is provided like a few factors. I'm going to illustrate to you to try these 3. So one positive, one negative, one fraction. Now let's start to write here. So I'm going to start the first one. So P at a negative 2. So this one is X plus 2, the factor. So let's say this one works out. This one works out. So we're going to put 2. Substitution negative 2, 3, add 3, and negative 2 exponent 2, minus 3 times negative 2, minus 2. So if you use the calculator, negative when you add together equals 0. So, and then P at negative 2, so it's a factor. Now, how about P at the positive 2? So it's equal 20. So it's not a factor. Now we're going to try and 2x plus 1. So we're going to write P. We solve this intercept. So x equal negative 1 over 2. So we write negative 1 over 2. So it's equal to times negative 1 over 2 exponent 3. It's 3 times negative 1 over 2 exponent 2. And then minus 3 times negative 1 over 2. And minus 2. Let's use the calculator to see what you get. Now, after your substitution, you're going to get this is a negative 1 over 4 and 3 over 4 and 3 over 2. So if you change the same denominator, this one times 2 equals 4, that's a 6. So you're going to have a 6, x3 is a 9. So 9 minus 1 is an 8. So if you change the denominator here for 4, it's also 8. So 8 minus 8 equals 0. So this is a factor. So we got 2 factors here for this polynomial equation. That's how you try to find factors. Use a calculator and use a formula. A formula is B over A to find the factor. So this A number is a B and that's an A. So I'm going to explain to you more examples how to find factor in a polynomial. Now let's do the next one. Now if you open the book on for the Ryerson Advanced Function Grade 12, page 97, Unit 2.2, Continual Factor Theorem, Example 2. So this is P and X, X exponent 3, at 2X exponent 2, minus 5X minus 6. So I'm going to illustrate how to find the factor. The A number is a B, the front number is an A. So that's the formula. We find all the factor in an A. So A is a 1, positive and negative 1. And we find all the factor in a B, positive and negative 1, positive and negative 2, and positive and negative 3. And the last one, positive and negative 6. But usually we need to try the front 2. in general. Now let's try it. Now let's try a positive one. I substitution positive one here into the function. I get negative a. This is not the factor. Now let's try positive 2. So I'm going to put 2 exponent 3. So I move the camera a little bit this side. So a2 times 2 exponent 2 minus 5 times 2 minus 6. And this one, when you calculation, that's the a, and that's a 4. 4 times 2 is the a, and that's negative 10 and negative 6. So we got equals 0. So therefore, this is a factor for x minus 2. So we find 1, and then we factor it first. Now we are going to make it in a long division. So you write it into a division box. Now we try cancel the first one. So x exponent 2, we get x exponent 3 minus 2x squared. So we subtract, apply integer, cancel the front 2, and you're going to get 4x squared. So minus 5x, so you're going to add 4x. So you are able to cancel 4x squared. And then minus ax. So you subtract it. You cancel these 2. So you have a 3x. So 3x minus 6. So you're going to try 3. So 3, you're going to get 3x minus 6. So it's fully divided. So I'm running out of room. I'm going to write it here. Yeah, make this will be 3x minus 6, 3x minus 6, subtract equals 0. So we finish this equation. So we're going to write it into the answer. So let's do it like, I will write the answer in the next page. And that's one way to do division, long division. So I'm going to show you how to do synthetic division, simpler. So we write this equation. So x exponent 3, coefficient is a 1. So 2, exponent 2, exponent 1, negative 5. The last is a constant, so it's negative 6. So I'm going to make the line here separate. Okay. So, and then from here, we already know the factor is x minus 2. So x minus 2, and we are going to write it into the synthetic division. Now we write the factor here, x minus 2 here. So the first number, you always straightforward, bring it down. So it's a 1. Now you do multiply. Negative 2 times 1, you get negative 2. So, and then negative, and this 2 is a subtract. The sign here is minus it. So minus minus, you get 8. So you get a 4 here. So a negative 4, negative 2 times positive 4, we get a negative 8. So minus minus is the 8. We get the positive 3. Now negative 2 times 3, we get negative 6. And subtract, you got 0 here. Now how are you going to write the answer? You're going to write the first one is an x. So exponent 3 will become a 2. So add the 4x exponent 1 at 3. So this is the answer, fully divided. Now from here, we're going to factor this quadratic. So I'm going to move it in the second page. So x squared, x4x, x3. So we can make it 4x, x3 times x at 1. So now the equation is fully factored, like x exponent 3 at 2, x exponent 2 minus 5x minus 6. So it's equal x at 3 times x at 1 and times x minus 2. So these 3 factors will be fully factored this polynomial. So we finish the example 2. So how to use the factor theorem? B over A find the factor for a 2, so x minus 2 to get it fully divided and get it and learn the synthetic division, and whatever left is a quadratic and factor with the quadratic format. Well done. We are going to do the next example. The next example is example 3 on page 99, unit 2.2. It's called combined factor theorem. So we have Ex.1-4. So and then we do the same thing, the same way to find factor. So and the use b over a. We find all the factor for a. A is a 1, so positive and negative 1. And b is a long because it's 18. So, but we try to use the front factor. A smaller number can solve it, like positive and negative 1, positive and negative 2, or positive and negative 3, positive and negative 6, and positive and negative 9, and positive and negative 18. So let's try only the front two first. So we're going to get the x minus 1. So let's try x minus 1. It works. So why I try a minus 1? So because the one here exponent 4, we create positive. Like let's try p at a 1. So that's x minus 1. So and then we are going to plug in. So I put the camera a little bit over this side. Okay, easy to read. So we're going to have a 1 exponent 4 f3 times 1 exponent 3 minus 7 times 1 exponent 2, 27 times 1 minus 18. So we're going to have a 1 f3 and minus 7 and minus 27 and minus 18. So is this work? Definitely. X minus 1 doesn't work. Now, if x positive 1 not work, we try negative 1. So negative 1, we get positive 1 at positive 27. We get positive 28. That's negative 10 and negative 18, negative 28. Positive 28, negative 28, we got the 0. Lucky, we got 1. So actually, this 5 factor is quite time consuming. Now, we're going to use long division, apply this x at 1 factor to find the answer. Now, let's write all the coefficient on top. So we're going to bring the first number down. I'm moving camera this side. So 1. So 1 times 1 is a 1. So 3 minus 1, we got 2. 1 times 2 is a 2. And negative 7, negative 2, we get negative 9. And 1 times negative 9, we get negative 9. And negative, we get positive. So negative 18. And 1 times negative 18 is negative 18. Subtract equals 0. Now, what answer are we going to get? So we get the answer is x exponent 3. At 2x exponent 2 minus 9x and then minus 18. Now from here, we got a cubic function. So we continue find the factor in this cubic function. Use the same formula, a over b. So let's try it. So there's 2 ways. So you can use the factor theorem, b over a, or by your eyes you can tell. So it looks like group factoring is work because 18 divided by 9, you get 2. So now we get a group factoring here for these 2 groups. So we're going to factor the first group. We factor x squared. So and then we're going to have an x at 2. Now the second group, we are going to minus, and we factor 9. We have an x at 2. Now from here, these 2 line term, we have an x exponent 2 times x at 2 and excuse me, because x exponent 2 minus 9, you can make it for a squared minus b squared. So I'm going to write the formula here. So a squared minus b squared is equal a plus b times a minus b. So we apply this formula here. We're going to make the room here. So I'll continue. So we're going to equal, so x squared, so minus 3 squared. 9 is a perfect square number. And then times x plus 2. Now from here, we're going to get x minus 3 times x at 3 times x at 2. So we're going to find the factor to solve this q-bar function. Now we're going to overall solve the function. So we're going to write the original function is x exponent 4 at 3x exponent 3 minus 7x exponent 2 and minus 27x minus 18. So what are you going to get? You get these three factors and plus the one x at 1. So we're going to put x at 1, the first factor, x minus 3, x at 3. Excuse me, I'm running out a little bit room here. So x at 2. So that's the final answer. So to make it clear, I'm going to rewrite the factor here. Will be x at 1 times x minus 3, x at 3, and x at 2. So these four factors is fully factor this polynomial function exponent 4. Yeah, since this side too tight, so I write the answer here. Now, example 4 is on page 100, same unit, 2.2. So it's giving you v and x equals 3x exponent 3 at 2x exponent 2 minus 7x at 2. So this function, you're learning rational factor theorem. So again, we apply the same formula. So a is a 3 and b is a 2. So the formula is b over a. So we find b, all the factor, and a, all the factor, and divide it. So let's do the 1. We find it's for the 1x minus 1. So use your calculator to try. Now if v at the positive 1, so what are we going to get? So we get 3 at 2 minus 7 at 2. So it's equal 0. So we find one factor. Now the next one, we are going to use a synthetic division to find the answer. So we are going to do it here. So x minus 1, we put minus 1. So and then subtract. And we got x here. Now we're going to put in all the coefficients. 3, 2. And 7 is negative 7 and a positive 2. So we write all the coefficients here. The first number is bring it down. So and negative 1 times 3, we get negative 3. So negative, positive, we get the 5. So and times we get negative 5. And then we get the negative 2. And then we get a positive 2 and 0. Now we're going to write the answer here. So the answer is going to be 3x exponent 2 at 5x and minus 2. So from here, we have to find a factor for this one. Yeah, and put a bracket and times x minus 1. So now for the quadratic, we're going to find a factor. Now we can make the combination, find combination for this quadratic. Now let's find 3x squared. So I put the camera like that. So it's equal 3x times x. So, and then how about 2? So 2, we're going to have a 2 times 1, we get 2. Now we're going to 5. 3 times 2 is a 6. 6 minus 1, you get 5. Perfect, you got it. So you're going to put 3x. And this is an x. So you want to get a positive 6. So therefore you add 2 here and minus 1. And you got the factor. Now, and the last one you just carry back here. X minus 1. And this factor is going to be equal to 3. X is bonus 3 at 2x squared minus 7x at 2. And a rational factor. That's how you solve it. It's not hard. So as long as you can find only the first one is quite time consumed. So, and you find the factor and reduce the exponent to the smaller degree. If quadratic, you can directly factor for quadratic. Even a cubic function, you can find it with a group factoring, or you can try the synthetic factor A over B to find it. So, and that's how to do factor theorem. So please practice to get it to be skillful and make your job find factor easier for the test. So this is Smart Kids Learning Center, the tutoring task. This is our contact number online. And we majorly tutoring all the high school math, especially for grade 12, advanced function calculus, as well as English. And if you like my explanation and in a simple way, so let's make a subscribe my video. I will continue efforts to explain the next unit, examples, and the chapter text to help your study. See you on the next video. Thank you. Bye-bye.